Hello guys, welcome to your channel. This is your math exam coach. Today we have a question that tackles arithmetic progression and geometric progression. But before we jump into this question, if you're new, make sure you subscribe to the channel. Make sure you follow our WhatsApp channel, which is going to be in the comment section. Make sure to share as well. Alright, so we are looking at this question, so you can pause and solve it, or you can follow along as well. So in arithmetic progression, we know that to find any term, we're going to say a plus and minus 1 plus the difference. And for a geometric progression, we know that an is equals to a times r to the power -1. That's for any term. So these are going to be key concepts here. We are also given that the first, second, and fifth terms are consecutive terms of a geometric progression. So let's first focus on the arithmetic progression. The first term is going to just be a, right? The second term is going to be a plus d. We're still using this formula. And the fifth term is going to be a plus 4d. We can do the same for the geometric progression. So the first, second, and fifth terms are consecutive terms. So with a1 is just equals to a, a2 is a to the r, and a3 here is going to be a r to the power squared. So now what we have here, we want to find a in terms of d. So we know that, let's go to the second part here. So we know that using these terms that we have, a is equals to a, so we know that for sure. And we know that a plus d, which is the second term of the arithmetic progression, is equal to the second term of the geometric progression, which is ar. Therefore, in this case, we can write r in terms of a and d, which is a plus d over a. But we also know that the fifth term of the arithmetic progression is equals to the third term of the geometric progression. Right, so a5 is equals to a3 here, so I'll call this q. This is for the geometric. So what do we have here? We have a plus 4d is equals to ar squared. Right. So since these are equivalents, we can write that a plus 4d minus ar squared is equals to 0. Right. So that's how we can rewrite that. And so a plus 4d minus a, but we know what r is, right? Which is, in this case, we have a plus d over a. Right, so now how can we do this? So now we can, this is squared actually, right? So since this is squared, so we have a plus 4d minus a all over. So this is going to be a squared plus ad plus ad plus d squared all over a squared. So what do we end up with? So we can come here, we have a plus 4d minus a multiplied by a squared plus 2ad plus d squared all over a squared. So this a will cancel this, and so we just have a here. This is equals to 0. So since this is equals to 0, we can multiply everything by a. So we have a squared plus 4ad minus a squared, so this is minus 2ad minus d squared is equals to 0. So some terms will cancel here. This 2 will cancel. So for ad minus 2ad is, we can rewrite this now as 2ad minus d squared is equals to 0, which we can say d squared minus 2ad is equals to 0. Therefore, we can factorize here d into d minus 2a is equals to 0. Therefore, d equals to 0, or d equals to d equals to 2a, which means a is equals to d over 2. That's what we really want to show. We want to show a in terms of d. Right? So we have shown that. And then the second question now says, given further that the difference between the first and last term is 36, find the sum of the terms. So we're given that, so this is the second. So we know that the last term here, our last term here is going to be a plus 9d, right? Because we only have 10 terms for our arithmetic progression. Therefore, the difference is going to be a plus 9d minus the first term, which is a, equals to 36. So we have 9d is equals to 36. Therefore, d equals to 4. Since d equals to 4, we know that from the previous question we said a equals to d over 2. Therefore, a is equals to 2. So now we also want to find the sum of the terms. So we know that here the sum of the 10 terms is equals to n over 2 multiplied by the first term plus plus the last term, which is a plus 9d. So this is the same as n over 2, 2a plus 9d. So therefore the sum here is going to be n over 2, so n is 10 over 2, 2a, 2, and our a is equals to 2, plus 9, our d is equals to 4. So if we simplify this, we should be able to show that this is 200. So we've combined both the arithmetic progression and the geometric progression in order for us to solve this question. Please make sure you like, subscribe, and also make sure you join our WhatsApp channel as well. Until next time, goodbye for now.